Hi, so I'm going to show you my Orrery. This is my Python program where I create the Orrery. I'm going to start running it, and it'll give me a second to start it. It's pulling up the file information. Here's the Graphical User Interface, and I'm going to create a simple Orrery where the sun is the center object, and just the inner planets, Mercury, Venus, Earth, and Mars. Okay, and I'm going to create an animation basically showing the planets every month for 24 months. Okay, so here's the GUI creating the visualization, and it's going to be basically an HTML file that runs on my browser. Okay, Python is running a Plotly file that creates a 3D visualization. This is all in my browser, so you can actually download these files, and they give you all this capability right off the bat. So here they are, and let me just show you how the visualization works. So you can see them, the planets going around their orbits every month for 24 months. So each planet is basically, okay, let's go back to today. So it's showing you the planet today, and then a month from today, and then a month from there, and each planet in its proper location in each month. So you can see that the Earth moves along its orbit. 12 months, it's basically back where it started. Mars takes about 2 years to go around its orbit, and Venus goes about 1.5 orbits every year, and Mercury many more times. So Mercury is here today, and in a month we've moved a little bit, and you can see that Mercury moved from here to here, about a fourth of its orbit. So that's why you see these crisscrosses, you know. It goes from this place to this place, and there's a line segment connecting the two, and that shows you the crisscross. The crisscross actually is kind of interesting because it's an illustration of how fast it's moving along its orbit path. Now, these are the actual positions of these planets that we're pulling from JPL horizons, okay? If I toggle off the orbit positions, what remains is the ideal orbits. Now, the ideal orbits are calculated orbits. They're not actual data. They're calculated using orbital parameters. They're also provided by JPL horizons. But the orbit paths are actual data. So even if you didn't have the ideal orbits, let's say we toggle the ideal orbits off, you still have the actual position. So in this case, we have both. Okay. What else can we show you? All right. So besides, there's two settings. So there's just the object names, makes it nice and easy and clear. We can also set full data, and this gives you more information. So for example, Earth's distance, velocity, and orbital period is shown. Okay, and there's also you can also open up the NASA website for each object, which is a nice feature. All right, so in future videos I'll show you more, but for now I think that's pretty good, and see you later. Thank you.